Hello everyone, welcome to Reactify Labs. Today we will talk about scaling. Okay, so what is scaling? Scaling is the ability of a system to handle scaling is the ability of a system to handle increased workloads or grow in capacity or grow in capacity. What does it involve? It involves it involves adjusting resources to maintain performance, reliability, and efficiency as demands fluctuate. As demands fluctuate. Okay. So, what is this exactly? What this technical definition means? This means that we have a system. Okay. Let's assume, or if you would have seen my other video in which I had talked about scaling your system from 1 user to 1 billion users, in that I had started with a one simple desktop application and I had added resources to it to scale it so that 1 billion users can use it at the same time, right? So this is scaling. Let me give you a good example. So let's say you opened a restaurant. Okay, you opened a restaurant. You did not know if it will work or not. So what you did was you hired only one chef. Okay. So initial few weeks, only one or two people came. One or two people visited your restaurant. Okay. Only one or two people visited, right? So, and one or two people is not a lot. It means the chef was able to handle the load. So let's say one person came at 9 a.m. Some other came at, or two people at 12 p.m. Then one person at 6 p.m. Then one more person at 8 p.m. So it was easy for the chef to handle the request. Okay. But you saw as time passed, so more people started coming. Let's say at one point you have only one or two people. The chef is easily able to serve them. Okay. But what if you have, let's say, 20 people at a time? 20 people at a time, right? So in that case, you will have to now scale your chef. Okay. You have to scale your chef now. That, okay, this chef should serve more than one people or more than two people at a time, right? So there are two ways to do this. One, you can add hands to chef. Earlier the chef had two hands. Now you can give this chef 8 hands, for example, or 10 hands, because this is very practical, right? For a person to have 8 or 10 hands, obviously I am joking, it's not possible, but in systems we can do that. I'll explain how. So either this, or what you can do is you can add new chefs. Okay, the chef can try to do some parallel work until maybe, let's say, four people. If four people came, the chef can have multiple parallel stoves running on, and the chef can do this. It can handle also till five people, but more than that, it's difficult for one chef to handle, right? So the chef can increase its power, the chef can do parallel work, but after one point it's not possible for one chef to handle every order. So now you add chefs. Okay, so this is what happens when chef increased, or you added hands to chef. Basically added hands to chef, it means you increase the power of a chef. So it is called vertical scaling. And when you added chefs, it is called horizontal scaling. So now you know that there are two types of scaling. One is horizontal scaling and one is vertical scaling. Okay. So great. Now let's come to the technical definition and explanations of these horizontal and vertical scaling. So what is horizontal scaling? You must have understood now from the example that in this we'll make multiple uh, processors or servers to handle the requests, right? Horizontal scaling is also called scaling out, and it involves adding more machines. It involves adding more machines or nodes, you can say machines or nodes also, to a system, to a system to distribute load. So we added more chefs to distribute load so that all the load of 20 people or 50 people does not fall on one chef, right? Right. Next, it allows for expansion of capacity, allows for expansion of capacity by increasing the number of servers, by increasing the number of servers running in parallel, right? So it's just another way of writing the first sentence, but first sentence was focused on scaling out. Second is, yes, we make the servers run in parallel, same as we made the chefs run in parallel. Okay. Next comes, it offers improved fault tolerance, better fault tolerance, scalability, and efficient load distribution. Efficient load distribution. Fault tolerance, why? If you increase the, let's say, power of one chef, you give 10 hands to one chef, but if the chef falls sick, it means all the 10 hands are of no use now, right? Your uh, business or the person who is responsible for cooking the food for your customers is no more coming to the restaurant now. He's going to take rest, so your business will be down for the next few days, which is not the case if you add more chefs. One chef or two chefs may become sick at one time. In the rare case, it is possible that all of your 10 chefs become sick, but not always. So the fault tolerance is improved. Similarly, scalability. You can always add more chefs, you can always add more servers to handle the increased load. Okay. And efficient load distribution means obviously each chef will have equivalent or almost similar amount of load. This, how this is achieved, I have talked about this in the load balancing video. Okay. And if you see, the cloud based applications utilize this. Cloud based applications utilize horizontal scaling. Utilize it. Why? To dynamically manage, to dynamically manage variable workloads and traffic spikes. Okay. So this is what horizontal scaling does. Okay. I hope this gives you some idea about horizontal scaling. Now let's move to vertical scaling. So, vertical scaling. As horizontal scaling was called scaling out, vertical scaling is called scaling up. It is called scaling up. What it does, it increases the capacity of a single machine. Scaling up, increasing a single machine's capacity by adding more resources such as CPU, RAM, storage. In the case of chef, it was more hands and more ears to listen to multiple orders at once, more eyes to see through all the orders, all the preparations going on at the same time, right? Next is its scalability is limited. Limited scalability. Why? Limited scalability due to hardware's maximum capacity. Due to hardware's maximum capacity, as it involves enhancing resources on a single machine. Enhancing resources on a single machine. Obviously, the example that I am giving for giving multiple hands to chef, it's not possible, but just hypothetically. Also, you can think of it like chef increases its speed. Okay, the chef tries to do everything in parallel, looking at all the stoves in parallel, things like this. Okay, but that is also limited. Okay, it's only a fixed amount of thing that you can do at one time. Maybe you can listen to music and do the cooking. You can listen to music and do two cookings at the same time, but not more than that. If you try to do more, 4 5, you will mess up. You will forget where you put the salt. You will forget where you did not put spices. You will forget what the spice level was required by the customer. Things like this will happen. So it's limited, but there is no limitation to how many chefs you can add, right? So horizontal scaling is not limited, but vertical scaling is limited. Okay, but its good thing is it simplifies management. It simplifies management and might suit certain applications, might suit certain applications or databases that require more resources. That require more resources. It means your restaurant had enough people to be handled by one chef doing things in parallel, but not enough to require more than one chef. Things like this. Okay. And next is it is used where applications demand increased resources. Applications demand increased resources and scaling up the existing server is a feasible option. It means the server is not yet at capacity. It means if the server is handling 2 loads, but it can handle 10 loads, we can obviously scale up it to handle 10 loads. If the chef can make 5 foods at a time, or 5 is too much, if the chef can make 3 foods at a time and it is still making 1 food because of the number of consumers, so as long as the number of parallel consumers at one time increases to 3, the chef is able to handle it. So it is vertical scaling, right? Okay, let's see now the side by side comparison between horizontal scaling and vertical scaling. Horizontal and vertical. Okay, as we have discussed, it involves adding more nodes. It involves adding more nodes, but this involves increased resources on single machine. More resources on single machine, right? Next is it increases number of servers. More servers or instances, and here more CPU power or RAM or storage or all also. Okay, what it does is it distributes workload across multiple nodes, right? And what does this do? It focuses load on a single machine but more powerful machine. On a single more powerful machine. Okay, it has improved fault tolerance, as we talked about this. Why? Improved fault tolerance, but this one has a single point of failure. This also I talked about. Why? One chef falls sick, restaurant closes. Single point of failure, right? Next is independent scaling is possible for each node. Independent scaling possible, right? Here scaling is dependent, so independent scaling is not possible. Okay, next comes it's more cost effective due to use of commodity hardware. So this is cost effective, but this has higher costs. May have higher costs, right? Next is its management is complex. Its management is complex, but for this simplified management. Why the management is complex? Because we have multiple servers and each server needs to communicate amongst each other to have the data consistency, to have the same data with in all the servers, to have the latest data. All the network overhead communications need to be taken care of. Okay, this will have less likely, it will be less likely to face hardware related bottlenecks, because we can always add more hardware, right? But this one may encounter performance issues, may encounter performance issues due to hardware limitations, because each hardware has a limit on how much power you can, how much more RAM, how much more storage, how much more CPU you can add to it, right? That's why. So it looks like most of the things horizontal scaling is better. So should we prefer horizontal scaling over vertical scaling always? No, there are some challenges also associated with horizontal scaling. So if you see challenges of horizontal scaling is one, ensuring data consistency, as I talked about it. ensuring data consistency across distributed nodes. Okay. Next is managing communication and synchronization. I just talked about this now. Managing communication and synchronization between nodes. All the nodes need to communicate to be in sync, right? Also, the applications must be designed to support distributed systems. So our application should also be aware that the system is distributed, the resources are on different nodes, and it should collaborate or communicate with each node before making any decision, right? So when should we use horizontal and when should we use vertical? If we have enough users, means if we not if we don't have enough users at the moment, then we should not worry about horizontal scaling. Okay, because at that time we will have a serious overhead or headache of managing multiple nodes, multiple servers, communication between them. But no, when your startup or the company is a very small sized or at a very early stage, when you don't have enough users and you think your one system can handle those many number of users, let's say your one system can handle up to 1000 users, then you should wait until you have 1000 or 10,000 users, right? So you should wait, okay, that right now we have only 1000 users, less than 1000 users. We should focus on improving our user experience. Okay, you should focus on different things. Now once you see that, okay, your product went viral and now you need to scale, then at that time you should focus on buying more servers and start focusing on horizontal scaling. Until that point, until the point of 1000 users or 10,000 users, if you see this can be handled, you should just go for vertical scaling. Okay, so I hope this clears everything about scaling, horizontal scaling and vertical scaling. I tried to explain it with all the different kinds of examples and real life scenarios that I could possibly do. So I hope you like the video. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.